Hello and welcome, scholars. This is our lesson on the distributive property. We're calling this lesson 1.4, just how it in general, chapter 1, section 4, it's the section out of the book that we kind of follow in here, but that doesn't matter as much as that this is a lesson on the distributive property. I always write my objective at the top of my notes. I would recommend that you at least start doing that and see if it's helpful for you, because this is exactly what I'm going to assess you over. I want to know that you can utilize the distributive property to simplify expressions, okay? So when you get a quiz from me in the coming weeks, you're going to know that I am going to quiz you on whether you can utilize the distributive property to simplify expressions. I want you to be able to prove this to me. That's why I always write those at the top of my notes. Now, the distributive property is hopefully something that you've already encountered in previous math classes. So I'm going to go through this kind of quickly and hopefully get to some more advanced distributive property ideas. But this is going to be very important when we actually get into the Chapter 2 content, which we will very soon here, and are solving equations. We've got to know how to do the distributive property and how that works and what it means. We also are going to use it throughout this year. For instance, we're going to get to like chapter 9, second semester, and we're going to need to take something really complex, but is in this form right here, and we need to take it back this way. For the most part this semester, we're going to be moving from this side where we've got parentheses to this side where we do not have parentheses. That's going to help us unlock expressions that have variables in them but are locked in this distributive property kind of idea with parentheses. So we are saying when we have the distributive property that we can have something multiplied by the quantity of something plus something, and we can break it down into that something times this other thing plus that something times this other thing. So I'm going to say that a little different. We've got A times the quantity of B plus C, and we know that that breaks down into A times B plus A times C. We know it does because no matter what number we put in here for A, B, and C, if I calculate this side, it's always going to be equivalent to this side. This is a rule in math. It always works this way. The distributive property can be written a little bit differently. For instance, it doesn't matter where you put this A. Same thing over here, because it doesn't matter what order we multiply something in. It's always going to give us the same answer. We can have negative signs in here. It doesn't change what we're doing with the distributive property. It's still giving us the same result. So in these examples, this is 3 times 4 plus 3 times 2. I like to draw these arrows sometimes to help me remember where I'm going with this stuff. It's always this A times the quantity of B plus C. So I'm doing 2 times 3, and I'm doing 2 times 5. And just as long as you get that thing outside of the parentheses times the first thing inside the parentheses and times the second thing in parentheses, you're always going to get this right, no matter where that thing is. Okay, a little quicker. 5 times 6 and 5 times 4. Now, there's a couple ways you could think about this part. You could think about this. How I like to think about this is a little bit differently. I would think about this as equal to 5 times 6. And I always put a plus sign here, times 5 times negative 4. Okay? But either way you think about it, this way or this way, you're getting a negative 20 here, right? If you think about it this way, you're getting a negative 20. But be very careful of these negative signs, okay? Make sure you're getting the right result. This is 8 times 4 minus 6 times 4. Okay, now we've got to move on to the examples that we are really interested in here in algebra, and that is an example with a variable, okay? So, but it's the same process, and like I said, I like these arrows. If that's helpful for you, use them. But we want to make sure that we're doing the thing on the outside times the first thing on the inside, the thing on the outside times the second thing on the inside. And so we've got 3 times x plus 3 times 2. We always want to simplify as much as we can. You can actually pretty quickly skip this step as long as you understand the first step. And we end up with 3x plus 6, okay? So we've got 2 times r and a negative sign, and we're just writing it right here, 2 times 4. This simplifies down to 2r minus 2 times 4 is 8. Okay. And here's this thing on the outside. Now you can either drop it into this spot or drop it into this front spot, but we're doing n times n, and we're doing n times 6. I don't care if you put the n here or the n here. Either way means the same thing. Anyway, what's n times n? Well, we write that as n squared, because that's exactly what this means, right? Do n 2 times, n times n, plus 6n. So anytime you see the word "you try," I want you to pause the video and try, and then watch me to make sure you did it right, okay? So you are pausing right now, you are trying, and then you're going to check the work based on what I did. I'm skipping this step for the "you try," okay? So I'm going to just jump to this step, and you're just checking your work. So 6 times 4 is 24, minus 6 times x is 6x. N times n is n squared, minus n times 9 is 9n. 3m times m, oh man. Well, there's no number to times by 3, so I've just got a 3 here, but m times m is m squared. So that's how we put that all together. M times m times, or 3 times m looks like 3m squared. Minus, we've got 3m times 5. Well, since these are number and a number, I'm going to do 3 times 5 is 15. Don't forget your m. Okay. Distributing with a negative can be a little more tricky. So we are going to follow the steps below. Just be careful with your negatives, okay? Sorry, the steps shown earlier. Be careful with your negatives. So same thing. This is -2, so we're multiplying everything on the inside by -2. We distributed our -2. What do we need to do now? We need to simplify. So this is -2 times x is -2x plus, well, -2 times 7 is -14. Well, how can we rewrite this? Well, adding a negative is just the same as subtracting, right? So we're going to rewrite this as -2x minus 14. Rewrite, add the opposite as subtraction. Okay? Rewrite that as a subtraction problem. We're going to see the opposite. Subtracting a negative is the same as adding a positive, right? Looks like we're going to see it right now. So we are distributing, and I'm going to say we're distributing 3y here, because that's what we're really distributing to these things inside this parentheses. Don't be weird. There's two parentheses, right? But there's only one term right here. Okay? Terms are divided by subtraction and addition signs. So this says we've got A right here, and we've got B minus C in here. So we know this A goes here and here. Well, what are we multiplying by? We've got 5, and we've got minus. They put the minus sign here. I don't care if you would have done a plus, a negative. It's going to give you the same thing. Minus y. And let's see what we've got now. We've got 5 times negative 3y. That gives us negative 15y. Minus negative 3y times y. So we've got negative 3y times y. Well, that's y squared. And here it is. Rewrite, add the opposite as addition. Addition, because subtracting a negative is the same as adding a positive. So we've got negative 15y plus 3y squared. Okay, subtracting a negative makes that a positive sign. One thing you'll notice is I'm left-handed, so I really apologize when I cover things up with my hand, but you'll get used to that like everything. So just wait a moment, and then you'll see what I wrote. I always say it out loud, which is why I say don't. Make sure you have the sound on as well. Ooh, this is interesting, but it's something you're going to actually see a lot. There's just a negative sign out here. But since it applies to both of these things in here, if this was an equation of some kind, we couldn't, I mean, we could divide, but we could divide by -1, but that's going to mess up the other side. We really just want to distribute this because I can't add to 11 to both sides, for instance, until I unlock these parentheses. So this negative sign, let's just think about it as -1. And you're going to see that a lot. We don't write -1 here because we don't have to. It's implied. Okay? So we're thinking about this negative sign as -1. So I'm going to put a -1 right here. We're distributing -1, or just distributing that negative sign. And it's going to change both of the signs for us. So in this case, we've got -2x. And this is minus a -11. Now we need to rewrite as addition. And I'm going to write this as -2x. What is the same as subtracting a -11? Well, that's adding 11. Now I'm going to, if you need this whole step right now, that's perfectly okay. But I'm going to really skip from here to here because there's not a lot of math in there. This is a -1 times -11. That gives me a positive 11. So I'm going to think about it that way. If you need to think about it this way, feel free, but it's your turn, so you are pausing and trying and coming back in a moment. I've got a -a times 3. Well, that's a -3a. I've got -a times positive a. Well, that's going to give me a negative number. A negative times a positive is going to give me a -a squared. So if you need to first time write that as a plus -a squared, that's fine. But we're getting to this in the end, right? Okay, so this is a negative. If you want to put -1 right there, if that's helpful for you, go ahead. But this is just basically going to change both of the sides. -1 times 2x is -2x. -1 times -11 is positive 11. Ooh, -3/4 times all of this. Well, that's going to give me a -3/4 p. And -3/4 times -1 is positive 3/4. Moving on. Sometimes distributed property isn't the only thing we have, okay? But it is always the first thing that we need to do when you see it, okay? It's not always the only thing that you have, but it's always the first thing that you do. Always start with distributive property. Exclamation point. And we're going to hit on that again when we oh my gosh. Always, I can't spell right now. Always start, I forgot an R. Oh my goodness, that was embarrassing. Always start with distributive property. We're going to hit on that again when we get to solving equations, but that's always what we start with. So I see distributive property. I like to use my arrows. And so I know I've got 2 times this and 2 times this. They put the negative sign already here for me. We're distributing 2. So what do we get? I get 2 times 6x. Well, that's 12 x's. Minus 2 times 4 is 8. And this is just riding along. This is just hanging out until I get to the point where I've got it simplified. And now we are going to combine like terms. So I've got 12 x's here plus 1 more x. Well, that gives me 13 x's. And I still have this minus 8. Same thing, I'm distributing -2. Distribute -2. And I get -2m and a -10. -2m's plus -4. Oh, these are m's and these are x's. Do I have like terms then? If this was an m, we could have done this, but this is not. These are not like terms, so we are done. I'm just going to skip down here. -2m minus 10 minus 4x. Okay. We are distributing. What are we distributing here? Are we distributing x? Are we distributing x minus 3? No, we only distribute the thing right in front of the parentheses. Notice this subtraction sign. We are now thinking about addition and subtraction signs, not as addition and subtraction signs often. We are thinking about it telling us whether the following term, this 3, is positive or negative, okay? We're always going to take an addition or subtraction sign with us when we think about distributive property and just about anything else in algebra, okay? So we're thinking about distributing a -3. Let's do it. I'm going to write down my x because he's just hanging out. He's just coming with. And so I've got -3 times x. Well, that gives me -3 x's. And I've got -3 times -4. I get positive 12. Again, if you want to write that as subtracting a -12, you can, but then you have to come back here. So now we need to think about this. These are like terms. They both have x's in them. This does not, so it is not a like term. So I've got an x minus 3 x's. 1x minus 3 x's. Well, that gives me -2 x's plus 12. And that's it. I mean, that's our answer. They put simplify here, so we could have done a -12. I'm not going to waste my time. So you pause and see what you can do down here, and then check your work. I'm going to move pretty quickly through this. So I've got 2 times 4a is 8a. 2 times 1 is 2. And I'm bringing this a with me. 8a's plus 1a is 9a. I am doing this times this, and this times this. I get 6 minus 3c's, and I still have this minus a c. Okay, this is just coming with us. What are my like terms? Well, I see two things that have c's in them, so I've got 6 minus negative 3 minus 1 is negative 4c's. Okay, this is all by itself. We're just going to go ahead and write this down to make sure we bring it with, but we're distributing this 2 in here. So I've got 2 times r is 2r. I've got 2 times 4 is 8. 6r's plus 2r's is 8r's. So I've got 8r plus 8. This is hanging out by itself. I've got 15t. We are distributing this negative. We're distributing a negative 1. So I get negative t, because negative 1 times t is negative t. Negative 1 times negative 4 is a positive 4. 15t's minus 1t is 14t's plus 4. Negative 6 times v, negative 6 times 1, negative 6 times v is negative 6v's. Negative 6 times negative 1 is negative 6. We still have this v, so I've got negative 6v plus v, I've got negative 5v, and we still have this minus 6. Last one. 6 times 5 is 30. 6 times negative z is negative 6z, plus we still have this 2z's outside of the parentheses. Negative 6z plus 2z's, well, that gives me a negative 4z's. And that is it. Please let me know if you have any questions, and you should know what to work on next.